In example 3, we have a racing car that's accelerating at 20 meters per second squared, 7 degrees north of west. And we're asked to find the acceleration of the car in the north and in the west direction. To do that, let's just make a quick coordinate plane here. And then I'll show the vector, and it's 70 degrees north of west. So our reference is west, and we want to go 70 degrees north of there. So this angle right here would be 70 degrees. That also means that this angle in standard position is going to be 110 degrees, and that's what we're going to want to use in our calculations. We could also use 70, I guess, in this case, but it's a little bit better to try to use that standard position angle. Also, the magnitude of this thing is 20, and it happens to be an acceleration, so I can write 20 here, meters per second squared. So we want to find the acceleration of the car in the north and in the west direction. So for the north direction, that's the vertical piece, what we're going to do is we're going to write y is equal to, and then we'll do the magnitude, which is 20, times the sine of 110. This would actually work out as well if you did 70. You'll still get the correct answer if you do that. If you type this in your calculator, make sure that you're in degree mode. You're going to get about 18.8, and the unit there is meters per second squared. Let's talk about the west direction. So the west direction will be x now, that's left and right, in this case left, and it'll be 20 times the cosine now of 110 degrees, which is about negative 6.8 meters per second squared. If you actually answered this question and said, what's the acceleration in the west direction, I would probably stick with just 6.8 meters per second squared. So you could have used 70 degrees for that. I just want to make a point that when we have the negative sign here in front of the 6.8, that means go left in the x direction, which in this case indicates the west direction.